Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 2, kinematics, subject physics. Today topic is equation of motion. In the equation of motion, we study first equation, second equation, and third equation is today topics. Equation of motions are the equation which give relation between time, final velocity, initial velocity, and acceleration and distance. So those equations which relate velocities with time, acceleration and distance is called equation of motions. Equation of motion. Velocity time graph is shown in the figure. This point represents the initial velocity. This point represents the final velocity. So when a body is given push from point C to point B or from point B to point C, velocity changes. Velocity changes. This is the graphical representation. Here, AC is equal to AC represents time. AC represents time. This is A, this is C. This line represents time. Time per journey. This time is equal to this time. Means AC is equal to OD. OD is equal to AC. You must memorize this thing because it will work in all the three equations. I will take it as a reference only. Now, this is called slope. This line is called slope. This will give you the acceleration. This will give you the acceleration. So, if a line is like this, you need acceleration. You need more force to climb. If the same line, taken the line from the same point and it is like this shape, you need less force. If the line is like this, near to time axis, you need to exert less force as compared to the other two to climb. So the height, this distance, the perpendicular and the base will give you the acceleration. The ratio of perpendicular to the base will give you the acceleration. Acceleration produced during their journey. So equation to a first equation of motion, equation per time, per velocity time relation by graphical method. So you have to do it graphically. And the second thing, if you look to the diagram, there is BC. BC is equal to CD BC is equal to BD minus CD. BD minus CD. BD is equal to VF minus VI. Equation for velocity time relation by graphical method. Let an object is moving with uniform acceleration. The acceleration is uniform during this journey. The initial velocity is represented by VI. This is the initial velocity. If the initial velocity is VI, let the object is moving with uniform acceleration A, and the final velocity of the object is VA during the interval time T. Now, area of triangle is equal to 1 divided by 2 base, which is time, into acceleration, which is hypotenuse. 80, 1 divided by 2, 80. I have written only in the order, so that's why A is written later and T is written first. So in this equation, an area of rectangle is equal to length cross breadth. Length is this line is represented by time. So you will write time and multiplied by initial velocity VIT. I will take these things as a reference in in the rest of the equation or on the other slides. So an equation which relate distance, acceleration, velocity, and time with each other is called equation of motion. Is BD is equal to VF. I already label it in the diagram. So here I have mentioned it for you people. CD is equal to VI and OD is equal to AC and is equal to time. So you should use slope of line AB will give you the acceleration. This will give you the acceleration. This will give you the acceleration. BC is equal to BD minus CD. I have written it for you in the first slide. And AC is equal to OD. It is also mentioned. This thing is equal to time, and this one is equal to final velocity. This one is equal to initial velocity. So V minus VI divided by T. So V is equal to V minus by cross product. Cross product. Cross product. Cross product. V minus Vi is equal to 80. V is equal to Vi plus 80. So we mentioned that BD is equal to, look at this one, BD is equal to final velocity. So just look at the diagram. Here point B is the final point, it is equal to VF. And C represents initial point. BD is equal to VF, CD is equal to VI, and OD is equal to T. You should memorize these are labels. These are the fixed representation. So slope of line AB is equal to BC divided by AC. The ratio of perpendicular to the base will give you the acceleration. More will be the perpendicular, more will be the acceleration. More will be the base, less will be the acceleration. So these are mathematical terminologies. BC is equal to BD minus CD. You can check this distance will be equal to the difference of these two. You can check it from the diagram. And AC is equal to OD. It's also mentioned in the diagram that it is used for time axis. So this is first equation of motion. Equation of motion which relate initial velocity, final velocity, acceleration, time, and distance. Give relation between these two quantities or relate these quantities with each other is called equation of motion. Diagram is must. If you cannot do the diagram, no need to attempt these equation of motion. Okay, so do it whatever means how much time it will take. Give it. Now second equation of motion. Distance covered by the object in given time t is given by the area of trapezium. In this case, we calculate the distance. We are going to calculate distance. So distance, you will calculate the area of trapezium. Because if you look to the first diagram, I will go back in this diagram. This side is parallel to this side. These two sides are parallel, and this side and this side is intersecting one. So it's a trapezium in which two sides are parallel and two are intersecting each other. Let in the given time t, the distance covered by the moving object is s. Distance is represented by s. You should remember that the area of trapezium, the given diagram, which is represented by trapezium is ABDOE, is the distance is represented by s. The distance will be represented by s, and this area will give you the area of trapezium will give you the distance traveled. The distance traveled. So in this case, area of triangle should be considered and area of rectangle should be considered. You should calculate these two separately. So when you take the diagram and you can calculate the complete area of the graph during the journey by calculating the area of triangle separately and the area of rectangle separately, you will get second equation. But if you calculate collectively, you will get third equation of motion. So go back to the diagram. There is too much lines. I will change the color of pen that you must know. This A, B, and C, this area is rectangle, triangle. So it will be calculated separately. And this area is rectangle, so it will be calculated separately. And you will sum up it. So when the area of the triangle is triangle is calculated separately and the rectangle separately, and you take the total area by taking the sum, then you will get second equation of motion. Let in the given time. So the area of trapezium, which is the distance. For example, this is the distance. Area of trapezium is the distance. Is the distance. So in place of this, you will write distance. The area of triangle and area of rectangle. you will calculate these, you will get second equation of motion. So distance traveled is equal to the area covered by the triangle and area covered by rectangle. So area of rectangle is equal to OA cross OD. OA is length and OD is breadth. So OA, oh, the value of OA is VI. OA is VI and OD is time. OD is represents time in the given diagram. OD represents time. And OA represents initial velocity. So this is the area of rectangle. Area of triangle is equal to AC cross BC. So area of triangle will be equal to area of triangle ABC is equal to 1 divided by 2 T cross AT. It's a mistake. No, it's okay. This is area of triangle ABC. So here 1 divided by 2, here is brackets, you will write in the brackets. In place of AC, you will write this one. And from first equation of motion, BC is equal to AT. I encircle BC. The value of BC from first equation of motion, it is equal to AT. So it should be written AT. Now put these values in this equation. I will write in this red equation. In this equation, in place of the distance, you will write S. Here you will write the area of triangle, and here you will write the area of rectangle. So area of triangle is equal to this, and area of rectangle is equal to this. So it is equal to S is equal to VIT S is equal to VIT plus half AT square. So if you calculate the area of the whole diagram, the area covered during the journey, by calculating the area of triangle separately and rectangle separately, you will get second equation. If you calculate collectively, you will get third equation of motion. And if you calculate the slope, the acceleration required for the slope, you will get first equation of motion. Third equation of motion. Third equation of motion is distance covered by the object moving with uniform acceleration is given by the area of the trapezium. So area of trapezium is equal to sum of parallel sides. Area of trapezium is equal to 1 divided by 2 sum of parallel side. There is no plus. Here is multiplication. Multiplied by distance between parallel sides. Distance between parallel sides. So the parallel sides is OA and BD. These are the parallel sides. And this is OD. So S distance is replaced by S 1 divided by 2. BD is written first and OA is written last. And here we will write OA. Now both sides is multiplied by BC divided by OD. BC divided by OD. So this will be cancelled with this one. You will get simply BC. So V plus VI cross BC. This term give you the this ratio will give you the acceleration. It is from first equation of motion, so it will be written here. It is mentioned for you people that BC divided by OD is equal to A, and BC is equal to BD minus CD. So BC is equal to BD minus CD. BD is equal to final velocity and CD is equal to initial velocity. So 2S cross A is equal to V plus VI cross V minus VI. So it is written 2S is equal to V square minus VI square. Here the formula is applied. A mathematical formula plus B A minus B is equal to A square minus B square. A square minus B square. So V is A and plus VI is B. So VA minus VI, V plus VI into V minus VI is equal to V square minus VI square. So this is third equation of motion. So let's revise. First equation of motion, you should calculate that the area of triangle separately and area of rectangle separately. You should take the slope of this side. From the slope of this side, you can derive first equation of motion. If area of this is calculated separately and area of this diagram is calculated separately, I will erase it and I will explain again. This will give you acceleration, and it is the ratio of this side to this side. It will give you first equation. If you calculate the area of this diagram and this diagram separately and then you take the sum, it will give you second equation of motion. But if you calculate the area of whole diagram collectively, it will give you third equation of motion. So memorize the simple steps. The slope will give you the first equation. The area of rectangle and triangle will give you the second equation, and the area of trapezium, this whole diagram area, will give you the third equation of motion. This is first equation of motion, in which BD is equal to V, CD is equal to VI, and OD is equal to T. Slope of line AB is the ratio of perpendicular to base. Perpendicular is equal to BD minus CD divided by OD. AC is equal to OD and it is equal to time. So AC is equal to OD, AC is equal to OD and it is equal to time. So it should be replaced by time. BD is equal to VF and CD is equal to VI. So it is replaced by VF minus VI. And simplification will give you the third equation of motion, the first equation of motion. Second equation of motion. You will calculate the area of trapezium. The whole diagram is called trapezium. That diagram you will calculate area of triangle separately and area of rectangle separately. Then take the sum, you will get the second equation of motion. Area of rectangle is equal to length cross breadth. So length is OA and breadth is OD. VI cross T. The area of triangle is equal to 1 divided by 2 AC cross BC, perpendicular to hypotenuse. Perpendicular to hypotenuse. So 1 divided by 2 T cross AT. So you will get second equation of motion by just taking the distance equal to area of rectangle, area of triangle plus area of rectangle. So you will get this equation of motion. So first equation is calculated by the slope. which is the slope of line AB will give you the first equation of motion, which is the ratio of perpendicular to base. Perpendicular to base, by putting and simplifying, you will get the actual value. The second equation is calculated by taking the area of trapezium complete diagram equal to area of triangle plus area of rectangle. So this area and this area, you will take the sum. When you take the sum, you will get second equation of motion. Area of triangle rectangle is this is the area of rectangle. Take this area, and this is area of triangle. You will take the sum of area. This is rectangle and this is triangle, and this is the sum. This is the sum. You will get second equation of motion by taking it equal to the distance. Third equation of motion is calculated by the calculating the area of trapezium. An area of trapezium is equal to 1 divided by 2 sum of parallel side. This is sum. This is one parallel side. This is the other parallel side multiplied by the distance between these two sides. So 1 is equal to V plus Vi cross OD. OD is written here. You will do this simplification by putting the value of BC, and then you will get this equation of motion. Thank you, students. It's today topic, and I hope you will understand. These equations are difficult, but try to do the more practice. More practice can make you perfect. So, and it is very important. If you cannot do this, it will make the to do the numerical and exercise difficult for you. So do it and revise it. It's good, better for you people. Thank you, students.